So, good morning, students. Today we will discuss a very important portion, that is concentration terms. Main chunk of the first chapter, that is mole concept, is based on the calculations of concentration terms. Concentration terms means what is the concentration in them? Means like when you are given a syrup, you can see that volume by volume percentage is written there. If you are eating oral pills, then weight by weight percentage is given there. These are concentration terms, and in some cases, that in seawater you will be given a problem that what is the salt content in the seawater. So there you will use parts per million or parts per billion. We will see that each terms with formula. First is weight by weight percent. Like in oral pills or medicines, you can see weight by weight percent. So what is the formula you have to remember here? Weight of solute upon weight of solution into 100. This is also called mass percent. In percentage composition, we use the same formula, like mass of particular element divided by total mass of the compound into 100. That we use mass percentage. So this is the first concentration term, weight by weight. Second, volume by volume. So volume of solute divided by volume of solution into 100. So like in syrups, volume V by V percent is given. So that is, suppose example like V by V percentage of NaCl is 10%. So 10 ml of NaCl is dissolved in 100 ml of water. Like that we can discuss. Third, weight by volume. So weight of solute by volume of solution. Means suppose weight by volume percent of NaCl is given as 10% again. So 10 gram of NaCl is dissolved in 100 ml of water. Understood? Fourth term is just reverse. V by W percent means volume of solute by weight of solution into 100. So like again the same example, that 10% of V by W of NaCl. So 10 ml of NaCl is dissolved in 100 gram of water. So first note down these four concentration terms, then we will move ahead. Okay. Next is ppm, that is parts per million. Let's look at the formula. Weight of solute by weight of solution into 10 to the power 6, that is 10 की power 6. means million you can see by 10 to the power 6 we are using for parts per million. So that the salt content in seawater, like that questions we can solve by this formula. Next is simple ppb, that is parts per billion. So weight, what was that, fifth, and this is sixth. Weight of solute by weight of solution into 10 ki power 9. That is billion you can analyze by 10 ki power 9. So chloroform content in organic solvent, that we can calculate by parts per billion. Seventh is mole fraction. Mole fraction means, suppose I am denoting A for a one substance, and B for second substance. I am denoting it. So the formula will be Na, that is number of moles of A by total moles, Na plus Nb. So from that I will get chi A, that is mole fraction of A I will get. Means you can see that number of moles of A are placed in the numerator and total moles are in the denominator, because I have to find chi A. So basic formula of mole you all know, that mole is equals to mass given by molar mass. This we all know. Also you have to remember that in this case chi A plus chi B is equals to 1. Chi A plus chi B is equals to 1. That is mole fraction of 1 plus mole fraction of second is equals to 1. This was mole fraction. So you can note down 5, 6, 7, and then we will move on to the 8th one. Okay. So 8. Molarity. Molarity is number of moles of solute by volume of solution in liters. So molarity means number of moles of solute we have to calculate and then just divide it by volume of solution in liters. Means this simply is giving us the concentration. Suppose we are given, I will give you a simple question to solve here itself. I am giving you a question that 35.5 gram of HCl is dissolved in 2 liters of solution. Calculate molarity. 35 gram of HCl is dissolved in 2 liters of solution. Calculate molarity. Simply you have to use this formula. Pause the video and solve the question, and then you can check the answer. I am solving it. So what will be the solution? Molarity is equals to number of moles. So how I will calculate? Mass given by molar mass mass given, sorry, let make it this 36.5, sorry, make this 36.5. So molar mass divided by volume in liter. You have to pay attention, volume of the solution in liter we want. So m is equals to 36.5. What is the molar mass? Calculate the molar mass. 1 plus 35.5, that is 36.5. 36.5 by 2. So 1 by 2 means 0.5 m. So this we can say like that also. 0.5 m of HCl is present. 0.5 m of HCl is present in the solution. Means the molarity is 0.5. That is concentration of HCl in the solution is 0.5. That way also I can frame. So you understood this molarity. What are the cases of molarity? That is very important. Cases of molarity. Many of the students are starting this chapter. It is the first chapter, and if you master this chapter, you will be mastered in states of matter also, because there is a relation in concentration. In 12th standard we will deal solutions. There you will see the use of this chapter, and the name of this chapter is some basic concepts of chemistry. Means you have to know this chapter very well. For knowing this chapter very well, you have to read the NCERT n number of times and solve questions related to concentration terms, because that are the main chunk of this chapter. So what we are discussing, cases of molarity. So dilution case. In dilution case, simply we will use M1 V1 is equals to M2 V2, where M1 is the initial molarity and dissolved in V1, and M2 is the molarity after dilution. This way you can solve simple questions using this formula. When you are given a question that a particular substance is diluted, what is the change in the molarity? So this we will calculate directly. Second, mixing. So for mixing we have a formula. Molarity after mixing is equals to M1 V1 plus M2 V2 by V1 plus V2. This formula you can directly use if two substances are mixed together, then find the resultant molarity. This formula is simply applicable for that. So these were the cases. Please copy it down, because many of the NEET and JEE questions are based on this small concepts. Okay. Ninth, molality. Don't get confused between molarity and molality. You can remember by Mr. R. Ritty and this Mr. L. Molality. So let's see the formula. Number of moles of solute by mass of solvent in kgs we have to take. Mass of solvent in kgs we have to take. So by that we will get small m, that is molality. Simple formula of molality. Now let's discuss other concentration term, that is normality. This is used in many chapters. Normality and molarity are used in many chapters. Equilibrium and many chapters they are used. Normality, we will see the formula. Number of grams equivalent by of the solute by volume of solution in liter. Volume of solution in liter. So how to find number of gram equivalents? So this we can find mass given by equivalent mass. So now how to find equivalent mass? Equivalent mass is molar mass by X. Now let's discuss cases of X. So for atom, X is the valency. For ion, X is charge on ion. For acid, X is basicity. For bases, X is acidity. For salt, X is total charge on cation or anion. Total charge on cation and anion. This is for X. To note down this please, because direct questions are framed on this. For atom, the X is considered as the valency. For ion, X is the charge on the ion. For Na plus 1, so plus 1 will be the X. For acid, basicity, number of H plus removed. Basis, acidity, OH minus. Salts, total charge, positive charge or negative charge. So let's revise normality. Number of gram equivalents of solute by volume of solution in liter. Number of gram equivalents, how we can find mass given by equivalent mass. How we can find equivalent mass, molar mass by factor X. So copy these two down and then we will see the next concentration term. Okay. So next concentration term is strength. Strength is equals to weight of solute by volume of solution in liters. Strength is nothing but weight of solute upon volume of solution in liter. So we have discussed 11 concentration terms, but 12th is formality which you have to just I will check if it is, what is the formula for it. It is weight of ionic is for ionic compound, weight of ionic solute by formula mass of the ionic compound into volume of solution in liter. This is extra for you, formality, weight of ionic solute by formula mass. Formula mass we generally take for ionic compounds into volume of solution in liter. So this is one question was asked in JEE for of this only. One question has came for of JEE and NEET. Slight question may come, but generally it is not asked. So these were the concentration terms. 12 concentration terms we have discussed. What are they? First, weight by weight percent, volume by volume percent, weight by volume percent, volume by weight percent, ppm, ppb, molarity, molality, normality, strength, formality, and mole fraction. 12 terms we have discussed. Now let's see the interrelation between these terms. Interrelation is another key topic of this chapter. So first write the heading, relation between x, that is weight by weight percent, and molarity m. Relation between weight by weight percent and molarity. So what is the relation? M is equals to 10x d by mwb. So x is as w by w, d is the density, and mwb is mass of solute. So this is the relation between weight by weight percent and molarity. What is that? We will revise. Molarity is equals to 10x d by mwb. Okay. Now another relation. I am rubbing it out. Relation between molality and chi, that is mole fraction. Relation between molality and mole fraction. What is the relation? Small m is equals to chi b by chi a into 100 into 1000 by mwa. So here mwa, many of the students have identified, that is mass of solute, mass of solvent, and chi b and chi a are the respective mole fractions. So let's revise. Molality is equals to xb by xa into 1000 by mwa. Simple is that. So we have finished the relation between molality and mole fraction. So I am rubbing this out. Now, very important relation. Many questions come from this topic only. Between molarity and molality. So molarity is equals to md by 1 plus mwb by 1000. This you have to learn, or you have to learn every relations, because that is a short question. One question always comes. So molarity is equals to molality into density by 1 plus molality into weight of solute upon 1000. So this was the relation between molarity and molality. Okay. Now relation between molarity and normality. So normality is equals to molarity into factor x. Short relation. Normality is equals to molarity into factor x. We have discussed about factor x 5 minutes earlier. That is the same case. Now let's move on to the next relation. Relation between molarity and strength. So strength is equals to molarity into weight of solute. Molarity into weight of solute. So these were the relations which we have discussed. A relation between molarity and molality, molarity and weight by weight percent, normality and molarity, strength and molarity, molality and mole fraction. Now, one more important question comes on hardness, to calculate the hardness. So let's deal with hardness. Hardness of water, how we can calculate. Marker star, hardness of water is equals to mass of calcium carbonate by total mass of water into 10 की power 6 into 10 की power 6. Hardness of water is calculated by mass of calcium carbonate by total mass of water into 10 की power 6. Okay. Now let's solve 2 to 3 questions because we are completed with the topic. So now it's the question practice. Just read the question. Okay. First, a simple question. 0.5 gram of substance is dissolved in 25 gram of solvent. 0.5 gram of solute is dissolved in 25 gram of solvent. Calculate weight by weight percentage. Calculate weight by weight percentage. So pause the video and comment your answer. Let's see who is commenting this question. Okay. If your answer is right, you will get a heart from me. Okay. Let's write the formula. Weight by weight percent is equals to weight of solute by, pay attention to now, many of the students have directly put the value down, weight of solution, pay attention to here, weight of solution into 100, weight of solute 0.5, weight of solution not solvent, weight of solution not solvent, so 25 plus 0.5 I will do. How much it will come? 0.5 by 25.5. Let's calculate half into 25 by 25, 25.5, 1 by 51. 1 by 51 is the answer. 1 by 51 into 100. So 100 by 51, it will come 0.1 point something 1.96. So 1.96% the answer is coming. Weight by weight percent is 1.96. So who got the correct answer? Let's see. Now I am rubbing and we will move to next sum. Pay attention to the solvent and solution mentioned because slight mistakes happens. Okay. Question 255 gram of an aqueous solution aqueous solution contains 5 5 grams of urea. Pay attention. Urea contains 5 gram of urea. What is the concentration of the solution in terms of molality? We have to find molality here. Find molality. So let's analyze, and you have to pause the video and give the answer in the comment of question number 2. So mass of urea 5 gram to 255 grams of an aqueous solution contains. Okay, now what we can do here? Okay, I will make it simple and write the formula. Make the question simple and write the formula. I will give you the molecular mass of urea, which is 60. You should learn the molecular mass directly. So molality is equals to number of moles of solute, which is urea, divided by mass of solvent. Pay attention to another, they are tricking you. Solvent in kg. So moles, how you can calculate? 60 we are giving. Okay, very good. 5 by 60 divided by mass of solvent. So this is the mass of solution. So minus it, simple. We will get 250. So ones are, and this will be 12s are. So 1 by 12 into 250. So here I will say 10 by 12 into 25. So the answer will be, it's coming very less, that is 0.332 m. Who got this answer? 0.332 m. Don't make that mistake by taking the mass of solute directly here. Wait, I have also done a mistake here. What? We want this in kgs. So yes, those who have analyzed the mistake, please comment down. 1 by 12, m is equals to 1 by 12 into 25. This was in grams. So by making it kg, I will multiply it into 10 to the power minus 3. So it will be 10 to the power minus 2 and 100 by 12 into 25. 25 ones are 4 by 12. 4 by 12, what is this? 1 by 3. So 1 by 3 I can write 0.332. Yes, 0.332 is the answer. So you have to always take the mass of solvent in kg. I done like that so that you can analyze the mistake what you are doing. You have to not consider this in grams but in kgs. So this was the second question. Now let's deal with the third question. Okay, what is the degree of hardness of a sample of water containing 48 milligrams of magnesium sulfate? 25 milligrams of magnesium sulfate, and molar mass is given 120 per kg of water. Per kg of water it's mentioned. Okay, per kg of water. Per kg of water. So what we have to calculate? degree of hardness. Hardness we have to calculate. So pause the video and comment your answer for question 3. Those who are commenting the right answer will get a heart from me. Okay, let's write the formula. First simple method, write the formula. Hardness is equals to, here the formula was of calcium carbonate, but we can, you know that hardness is affected by MgS of SO4 also, so we can consider that also. So mass of MgSO4 by total mass of water into 10 की power 6. So mass is 48 into 10 to the power minus 2 we take na for milligram. We take minus 2 by total mass of water, which is 1 kg, so 1000. So milligrams, so I will convert this into also 1 gram, so 1000 gram, yes. One, two, three zeros will be cancelled. 48 into 10 to the power minus 2 into 10 to the power 3. 480 we are getting. 480 we are getting na. Why I am not understanding why they are giving the molecular weight of that, but in hardness we generally use mass of MgSO4. Let me confirm this question, or you can solve and comment with the answer. Now let's solve a question based on relationships. Last question for the day. Question 4. If molarity is 1 m and density is 1.2 gram per ml, MWB is weight of solute is given as 50 gram. Calculate molality. Comment me this answer also. Relation we are using, M is equals to MD by 1 plus M small m MWB by 1000. So here M is 1.2 by 1 plus M 50 grams, 50 by 1000. So 1.2 m by 100 plus 5 m. So this will go here. So 100 plus 5 m is equals to 1.2 m. 100 is equals to, it's coming in minus because I have made the sum. So what you have to not look at the answer, but the way in which we are solving to come to this point. And we have to remember this formula. This is the main interconversion formula. The values are taken in such a way that the answer is coming in minus, so leave this problem because we have to not deal with the answer, but we have to solve the major step because calculation तो आप लोग कर लोगे. I am giving you the concept, and direct questions generally are not asked. The combined questions, right? Degree of hardness, such kind of questions are framed. So this was the whole about the concentration terms in first chapter, mole concept. Shorts are also uploaded on this channel only for you to solve multiple questions and different variety of questions. So thank you for watching, and comment your answers below, or you have any doubts regarding this topic, and which topic should I take next in chemistry or biology. You can ask that. Thank you.